Good morning. I am Varalakshmi from Department of Civil Engineering, Varalakshman Reddy Institute of Technology and Management. In this lecture, I am going to discuss about the types of spillways. So, spillways are classified as many types depend on their utility, purpose, and provisions. So, first classification is based on utility. Spillways are classified as two types: main spillways and emergency spillways. Next, second category based on hydraulic design features: straight drop spillway, Vogie spillway, side channel spillway, chute spillway, conduit spillway, shaft spillway, siphon spillway, and saddle siphon. In siphon spillway, again they divided into two types: saddle siphon and valute siphon. Based on whether gate is provided or not, they are classified as gated spillways and ungated spillways. The main spillways is the one which is called upon to work under design floods. So main spillways are worked under design flood. So the water passing, main water is passing. Emergency spillway. The name itself represents emergency. When they are when the engineers feel the dam may fail due to excess water, then the emergency spillway may open. Emergency spillway is provided on a project for additional safety in case of emergency. So the water is coming in excess of design, in excess capacity of the spillway. Then the emergency door will open. Their functioning is required under the situations caused by an enforced shutdown of the outlet works or malfunctioning of spillway gates, or when a flood greater than the design flood occurs. So when the gates, spillway gates are not functioning proper, or the flood occurring is more the capacity of spillway, then emergency spillway is worked. The crest of the emergency spillway is kept at or above the designed maximum reservoir water surface. They are normally provided in earth and rock fill dams to avoid overtopping of the main dam embankment during emergencies. So here you can see this is the earth dam, main water. This is the main river. Yeah, on the earth dam spillway is not possible, so here the main spillway is constructed here. The emergency spillway is constructed here. So the water is releasing from main spillway. If the functioning of the spillway is not regular, or any dam, or the water is more, then automatically emergency spillway will open. Next, first type of spillways: straight drop spillways. This is the simplest type of spillway, which is constructed in the form of a low height wave having downstream face vertical or nearly vertical. This straight drop spillway is very easy to construct. It is generally constructed for low height waves. Waves means it is the structures constructed on the river to control the velocity of flow of water. Okay, already in hydraulics and hydraulic machine lab, already we are done practical on the waves and notches. So for that waves, this straight up spillway is constructed. This spillway is used for low height dams. Water drops freely from the crust. Water is flowing from the crust like this. There is no shutter. This is the crust part. So water flow freely from the crust. The underside of the falling nap is ventilated sufficiently to prevent the pulsating and fluctuating jet. So, to control the force of water and jet of water, the, the end is provided like this, spillway with overtopping. So, we can provide like this. Sometimes the crust is extended in the form a overhanging. So depend on the structure, we must provide like this, or it may extend it like overhanging lip. For protecting downstream side, an impact block basin with apron is provided to dissipate the energy. So to dissipate this water energy, the floor is provided with apron. So you can see this one is the apron. The apron is constructed with concrete, soil, gravels. So this is the apron. The apron protect the downstream floor from erosion. Next, very important is the Ogi spillway. This is the most common type of spillway provided on gravity dam. The profile of the spillway is ogee shaped and adapted for high dams. So the profile of the spillway is in the ogee shaped. The water is flowing in the ogee shape. That's why it is called ogee shaped. It is constructed for high dams and it is stable structure. Nagarjuna Sagar, Srisailam dams, almost dams in Telangana having the Ogi spillway only. The overflowing water is guided smoothly over the crust and profile of the spillway so that the overflow water does not break contact with the spillway surface. The top of the spillway makes this is the top of the spillway, so it should be compulsory smooth in nature. Okay, it should be provided smoothly because overflow water does not break due to spillway. If what will happen if it break, the water touches the downstream wall or then it may fail fail. So the Vogi spillway, a top crust should be very smooth. If this is not assured, a vacuum may form at the point of separation and cavitation may occur. So, if it is not assured, automatically what will happen? A vacuum at the any point or cavitation may occur on the downstream wall. So, to avoid that one, the OG shape crust is very smooth and in the shape of OG. In addition to cavitation, vibration for alternate making and breaking of contact between the water and surface may result in serious structural damage. That is, I discussed already. Hence, the upper profile of the Vogi is made to conform with the lower nap of a freely falling of jet of water over a sharp crusted way. So, the upper profile of Vogi is lower freely falling nature. You can see the Vogi spillway. So this is the reservoir. This is the crust of the Vogi and the shape is like this one. And here we are providing stilling basin and below the stilling basin we are providing apron. Okay, so this is the shape of the Vogi like this. What is the Vogi profile? First one, the degree Vogi profile consists of downstream curve, downstream tangent portion, downstream reverse curve, upstream curve, upstream beta. So first you can look at this figure. So this is the ogee shaped spillway. This one is the crust axis. It is the curved path. This center is the point of tangency. That means how much curve we will provide. And this is the straight. The 0.7 to zero point 0.7 is the slope. And downstream angle. Downstream angle is 60 degrees. Okay, so P is the Z is the total water level, where HD is the head of the OB. Okay, this is the profile of the OB. Next, you can take this figure, practical profile. Similarly, in the gravity dam, first we are giving elementary profile, then it is converted into practical profile. Similarly, here also, first we are taking elementary profile, then it is converted into practical profile in spillway design also, because it is attached with the dam. So here A, figure A. You can look at it, figure A. So this is the dam shape. First initially triangle. Then we are provide top of the dam, top width, and the triangular section is changed. So in changing, the slowly the vogue is developed. Okay, here you can for developing of Vogie profile, the downstream wall is thickened. Slowly after this one thickened the downstream, upstream extended the Vogie shape into the reservoir, because water is entering into the top. So the upstream, the Vogie entrance projectile, that is known as projecting corbel. That is concrete saved. Okay, it is top of the normal pool level, maximum reservoir level. Okay, these are the profiles of the Vogie spillway. You can see these all are Vogie spillway structures. So this is the spillways. How many spillway gates? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 gates are there. Okay, so this is the another example of Vogie spillway. You can see this is the Vogie shape, and this is the basins. Okay, Stirling basins, hydraulic jumps. So you can see water is flowing, water is coming from there and flowing. This one is the hydraulic jump. You can from this one to this one, it is the hydraulic jump. So water is flowing into it and the jump is taking place. You can see it is the Vogie spill. So maximum Indian dams are provided with Vogie spillways due to its simplicity and the standard of the structure. So this is the another example of Vogie spillway. Next important one is the side channel spillway. A side channel spillway is the one in which the flow after passing over the crust is carried away in a channel running parallel to the crust. Okay, a side channel spillway is one in which The flow, after passing over the crust, is carried away in a channel running parallel to the crust. That means the original it is the name itself represents it's a side channel. So the water carries to the carried away from running channel to another channel suitable for earth and rock fill dams. So it is suitable for earth and rock fill dams in narrow canyons and for the other situations where direct overflow is not permissible. Mostly in earth dams, we are providing side channels spillways. Ogi is constructed maximum on the dam itself, but side channel is constructed in separate place. Okay, like emergency and exit you can see now. So it is the side channel spillway. Here we are providing side of the dam. So here it is the side channel spillway. You can see. So this is the dam. The spillway is provided here. The water is coming to the river from the side of the dam. The water is entering into the river from the side spillway. Okay, so you can see this is the original dam. Okay, this is the original dam. But here the spillway is not provided. So they are constructed at sides of the dam. These are the side spillways. Okay, so it is side channel spillway. The water is coming released from upstream to downstream through these two channels, not from the dam. It acts as a barrier wall, retarding wall, but the water spillway is provided here. So maybe it is in the shape of open channel or in the shape of conduit. So it is in the shape of conduit. Okay, it is also one form of the side channel, gated side channel spillway. Next important one is the chute spillway. A chute spillway is the one which passes the surplus discharge through a steep sloped open channel called chute or trough, placed either along a dam abutment or a saddle. So, a chute spillway is also provided to discharge surplus water, but where the Voge is a straight sloping channel. But chute is like a steps. That means in fountains are providing water is coming on the steps. In the same way, chute is provided with the steps, not the slope. Okay, this is type of spillway is provided in earth and rock fill dams and is isolated from the main dam. It consists of a discharge channel to the river in an excavated trench which is usually poured with concrete in a hole or in part. The chute is sometimes constant width but usually narrowed for economy and then widened near the end to reduce the discharge velocity. Chute spillways consist of entrance channel, control structure, discharge channel, terminal structure, outlet channel. So the chutes are provided here. So the chutes are provided here. Chutes means steps. So the water is passing from the river to chutes. The crust spillway may provided on the dam near or side of the channel. So you can see reservoir and the dam. Side channel spillway. Here the stilling basin, these are the chutes. Cross section chutes. Okay, you can see. So these are the chute channels. So here one step and the is is one step. You can see how the water is coming. So you can see here steps like one, two, three. So the water is coming like this. So these are the drop chutes spillway. This is the another chute. Here from here to here, chute design is different. Steps are different, and from here to here, the chutes are also different. Okay, you can see these different chutes. Okay, so these are the chute channels. So next we are going next spillways are discussed in the next class. Okay.